Good morning, everyone, and welcome to the December Pacific Northwest DEWS Drought and Climate Outlook Webinar. Thank you to those that have joined us previously and those joining us for the first time at this webinar today. My name is Megan Dalton, and I'm with the Pacific Northwest Climate Impacts Research Consortium, or CIRC. For those of you who are accustomed to hearing Kathy Dello introduce these webinars, I am taking over for her as she focuses her time and energy on other important activities within CIRC and also on her dissertation. So this bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. This webinar is being recorded, and it, along with the presentation slides and a 2-page summary flyer, will be available on drought.gov later this week. On the agenda today is a year-end climate recap presented by John Abotsoglu. He is a CIRC researcher at the University of Idaho. And then we'll have Andrea Baer with the National Weather Service Western Region, who will give us a winter climate outlook and an update on La Niña. And then finally, Gabrielle Roche McNally with the Northwest Climate Hub will present some highlights from the draft Northwest chapter of the 4th National Climate Assessment, which is currently open for public comment. So just a reminder, if you have any questions, please feel free to use the chat box or the question box, and we'll take your questions at the end. And so with that, I'd like to introduce the new NIDIS Pacific Northwest Regional Coordinator, Britt Parker.
Great, thank you. So I wanted to just take a minute to say that I'm very excited to join NIDIS and really looking forward to working with you in the Pacific Northwest DEWS. Before I give an introduction to NIDIS and the Pacific Northwest DEWS, I just wanted to briefly give you a little detail on my background and where I come from. I've spent the last 10 years at NOAA in the Office for Coastal Management and the Coral Reef Conservation Program in Silver Spring, Maryland, where I manage their climate and international portfolios. And so while the topic of drought is new, I spent much of my time focused on the delivery of climate information and services and developing decision support tools for our management partners, building networks and communities of practice. And then specifically, I managed a project to strengthen climate early warning systems for nearshore marine resources, water resources and drought, and coastal inundation in the Pacific Islands. So while the topic of drought is new and providing a great new challenge, the approach to the work we do is quite similar. So I just moved to Boulder and joined the team here about 6 weeks ago, so I'm definitely still on the learning curve, but I've already had the opportunity to chat with some of you and look forward to the opportunity to meet you all virtually or in person in the coming months. So I just want to quickly give a little introduction to NIDIS and the Regional Drought Early Warning System. So let's begin by answering the question, what is the National Integrated Drought Information System? So the goal of NIDIS is to provide, to improve the nation's capacity to manage drought-related risks by providing the best available information and tools to assess the potential impacts of drought and prepare for and mitigate those effects. So we want to improve our understanding of how and why droughts affect society, the economy, and the environment, and improve accessibility, dissemination, and use of early warning information for drought management. So NIDIS's approach to achieve that goal is to build the foundation of a national drought early warning system through the development of regional drought early warning systems, or DEWS, where networks of partners and stakeholders share information and actions to help communities cope with drought. So while the ultimate, yes.
Sorry, could you fast forward your slides? We're still on the first slide.
Okay, yep. So while the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across regions. So what is the drought early warning system? Each DEWS has many of the same components or ingredients, which includes observation and monitoring, predictions and forecasts, planning and preparedness, communication, outreach, and interdisciplinary research and applications. And the intent is through that to build capacity for better decision making, to support the collection of and provide access to data, educate the community on climate and drought science and information through forums and webinars such as this, to do drought and risk assessment as well as post-drought impact assessment, and build capacity around the use of existing tools and products as we work with users to improve upon them. And finally, to develop new and use existing communication networks with key stakeholders. So the Pacific Northwest DEWS was officially launched in February 2016 after a year of regional scoping workshops and and outlooks to collect feedback from stakeholders in the region on needs. The strategic plan is now available on drought.gov, which provides a roadmap for moving forward and identifies existing and new drought-related activities in the region. And so this is a living document with a 2-year time frame, and you can see some of the priority areas which have been identified at the bottom of the slide. So before we launch into our first presentation today, please mark your calendars. This is a bi-monthly webinar series hosted by NIDUS, CERC, the Northwest Climate Hub, the National Weather Service Western Region, and others. And it's designed to provide you up-to-date information on timely drought and climate information. And each webinar will be tailored to reflect recent, current, and forecasted conditions, and may also include discussions of observed impacts and other relevant updates. So our next webinar will be in February of 2018, and we will be reaching out to determine if a Monday morning is the best time to do this webinar for the most people to be able to join, so stay tuned. And as Megan said, the webinars and recordings and other supporting material will be posted on drought.gov. So with that, I'll turn it back over to Megan.
Britt.
Yep.
Oh, yeah, thank you, Britt. Sorry, we're all still seeing the first slide of your presentation.
Sorry.
I wonder if you could try to advance through, take a minute to advance through slowly so folks can see.
Yeah, let's see. I'm not sure why. Can you see them now?
Yes,
okay.
They are advancing.
They're advancing. They were advancing on my computer. So hopefully that's the biggest technical glitch we have today. So we went through, can you see them now? So the NIDUS, what is NIDUS? And then we had the components of the regional early warning system. A little bit more information on the Pacific Northwest DEWS. And mark your calendars for our next webinar, which will be in February 2018, and we'll be communicating more about that via email.
All right, thank you, Britt. And these slides will be available after the webinar if you want to take more time to look through them too. Okay, so our next speaker then is John Abatsoglu at the University of Idaho. And he'll give us the climate recap. So go ahead, John, when you're ready.
Okay, you can see my screen here.
Yes, we can.
Okay, so great. So my task here is to get everybody up to speed in terms of where we are, in terms of the current situation from a water perspective, and then talk a little bit about sort of what has transpired in 2017. We had a very interesting year climatologically, including an incredibly wet first 6 months of the year, followed by just as incredibly dry summer. So it's been a bit of a roller coaster, and I wanted to sort of walk you through that. And I'll specifically be focusing on what has transpired so far this fall in the first couple weeks of climatological winter. So here's the drought monitor as it stands today on the right, and in comparison where we were a year ago at this time. And so across much of the Northwest, we're relatively well off. There's a little bit of drought to D0 drought showing up across northwestern Montana, and that extends to a more pronounced drought in the upper Great Plains in eastern Montana. And one of the reasons that we have relatively drought-free conditions across the Northwest is if we look at the calendar year precipitation to date, it's been incredibly wet across parts of the Northwest. And this is from the Westwide Drought Tracker. And so at least across much of the mountains of south central Idaho, we're talking about the wettest January through November on record. That's 120 some odd years. And the overabundance of green across the Northwest is showing that we've had a pretty healthy dose of precipitation so far in the calendar year, and that'll be obviously pretty important in terms of where we are today. It's also been pretty wet across recently across parts of the upper Snake into the Yellowstone region. And if we look at what has transpired so far this fall, I have two plots here. On the left-hand side, this is temperature, and these are expressed as a percentile. So anything in white is pretty much near normal. Anything that's yellow there is in the top third of the distribution for September through November. And so Pretty normal temperatures across the Northwest, a little bit above normal, but nothing remarkable. Precipitation-wise, we can see a lot of green on this map as well. Pretty wet across the Northwest, not incredibly wet, but above normal overall from September to November. And we had a pretty healthy snowpack, you know, around Thanksgiving or so, and that's changed dramatically. And so that lets me talk a little bit about what's transpired over the past 2 weeks, since we have had a bit of a regime change. Something that we do see, you know, from time to time in the winter, we get these pretty nice patterns that get locked in. And the pattern that we've seen basically since the 1st of December has been one where we've had a very large ridge over the western United States extending up into British Columbia. And with this sort of ridge pattern, what ends up happening is that, I depict the black line here, this is sort of like your jet stream. The jet stream has been shifted way up to the north. It's brought some incredibly warm air across parts of Alaska and some precipitation up there, leaving much of the Northwest, and of course, we've seen in the media, the southern portion of the western United States high and dry. And this sort of ridge-like pattern is, again, like it happens, you know, fairly regularly in the wintertime. This corresponds fairly well with a positive phase of the Pacific North American pattern. We get this sort of ridge that gets set in. We have, you know, below normal precipitation as the jet stream gets shifted up to the north. And temperatures are warmer than normal if you go up above the fog. But what's interesting is if you look at, well, first we'll start with precipitation. So here's precipitation the last 15 days. These are some products from the Northwest Climate Toolbox that we distribute and we update daily. It's a CERC product. So precipitation percent of normal, not much over the last 15 days. We have picked up a little bit recently this past week, and at least here in sort of Moscow, Idaho, the Panhandle, Eastern Washington, quite a bit of snow, actually 6 to 7 inches of snow here in the last couple days, but way below normal. This is the wet season. It should be raining quite a bit more. We haven't seen much, and that corresponds pretty well with the big ridge. What's interesting from a temperature perspective is that, yeah, it's been warmer than normal if you go up, but if you stay down low in the lower elevations where you're socked in by the inversion and fog, it's been cooler than normal. So interestingly enough, if you look at the temperature departures from normal over the past 15 days, it really depends on where you are. And again, that's pretty typical of what we see when we have these relatively quiet weather patterns in winter. One thing that really shows up that I think is going to become important and something that we will keep watching for throughout the winter is our snowpack. And the snowpack has fared quite poor over the past month or so. And this plot here is showing us the snow water equivalent anomaly. So basically, we're looking at how much snow has accumulated versus how much snow usually accumulates over this 4-week period. And there are areas where we are 8+ inches behind in terms of the snowfall accumulation relative to normal over the past 4 weeks. So that has really taken a damper in terms of what our snowpack looked like a month ago and what it looks like today, and that's depicted here. So on the left-hand side, that was the snow water equivalent percent of median on November 20th, healthy snowpack above normal, and what it looks like today. And we are seeing a number of SNOTEL stations, specifically across Oregon, that are reporting numbers that are incredibly low in the sort of the bottom 10th percentile. So we'll keep an eye on that. One thing that we do know is that we still have a lot of season left to go when it comes to accumulating snow. Just for instance, across northern Idaho, by this date, we typically have accumulated about 30% of our snow for the year. So that tells us we have a lot more season to go. But nonetheless, we have lost quite a bit given the combination of this ridging pattern. And we also had, in late November, we had an atmospheric river come through that brought incredibly high snow levels, warm temperatures, and that caused a dramatic melt out. We had flooding across parts of western Washington. So the combination of those two has basically taken a big bite out of our snowpack. So the current water year as it stands precipitation-wise, it's a bit of a mixed bag. You know, a little bit above normal in certain parts of Washington state, a little bit below normal in central Oregon and also in eastern Idaho. And again, it's a little bit early, of course. We still have a lot of season left to go, but it's a bit of a mixed bag in terms of precipitation. The snowpack, though, is relatively poor for all regions except for perhaps the Upper Snake. So that's my summary, and I think we have seen a roller coaster ride in terms of precipitation and drought over 2017, and that has continued so far into our current water year. And again, we'll keep an eye on that snowpack. Oregon is hurting the most right now, but that can change pretty rapidly if we get a pattern that is basically the opposite of what we've seen recently. And I think I'll end there. We'll hear a little bit more about what's coming up in terms of the seasonal climate forecast.
All right, thank you, John. So we'll go ahead now to Andrea Baer, and she'll present a climate outlook. So go ahead when you're ready.
Thanks, Megan. Can you see my screen?
Yes, we can see it.
Okay, fabulous. Thanks. And John set that up really well for me. So thanks, John. Always a good speaker. So I'm going to be presenting the climate and drought outlooks, what we know at this point in time. And this is just a graphic or a little cartoon of a typical La Niña wintertime pattern. And you can see that generally we expect this more amplified ridge to be between the Aleutians and the Gulf of Alaska there. And as John mentioned, lately it's been shifted a little bit towards the east and causing some troubles for us in the western U.S. So right now, globally speaking, La Niña conditions are pretty solidly in place, meaning that the ocean, the cool ocean waters in the central Pacific and the eastern Pacific are corresponding very well with what's going on in the atmosphere. So they're coupled very nicely. This is typically what we would expect globally for a La Niña. Much more, I would say, than our La Niña last year. Our weak La Niña last year definitely did not behave in a more typical fashion of what we expect with La Niñas. But I'm going to show you a little bit of history in just a minute of La Niña events. So La Niña is expected to continue through at least the beginnings of spring this year. So it's expected to be a weak to moderate event and not terribly long-lived. As we go through the spring, we should be moving back towards ENSO neutral. I know this graphic's very busy, but stay with me here. I got these graphics from climatic.gov at the NOAA ENSO blog. I highly recommend, if you want some good graphics on ENSO, to go there and look at that ENSO blog. But stay with me, I know it's busy. Okay, so on the left side of the screen here, these are all of the La Niña events, not including the one last year, though. I'm sorry about that. It does not include last year's, but all of the La Niña events since the beginning of when they started keeping an observed history of those, so since about 1950. And they're ranked in order of strong. So as you go through here where my pointer's going, those are all of the strong La Niña events. And then it moves into moderate, and then it moves into weak. And again, we're expecting a weak to moderate event. But the real thing I want to scream out at you here is there is a lot of variability. When we say, oh, yes, this is reacting like a typical La Niña in the Pacific, etc., it still means there is a lot of variability. And I know everyone on this phone has experienced, like John said, last year's La Niña didn't react in impacts the way that we would expect for a typical La Niña at all. And then also with the strong El Nino before that, things did not the impacts did not manifest themselves in the way that we always expect. So my point in this slide is not all La Niñas are the same, and that's definitely something to keep in mind. If we go back and look at the 21 different La Niña years and do a statistical composite, so what are some of the typical tendencies when we average all of those events together? If we average all 21 together, you can see with temperatures that in the Pacific Northwest, things tend to be on the cooler side. But this is interesting. Somebody at the Climate Prediction Center did this little composite, and it's interesting because if you split the events in half, so 10 and 10 events, so if you split that on the 1985, this is what you got for all those events prior to 1985, and this is what you get after. So if you're looking in the Pacific Northwest with regard to temperatures, you can see the signals washed out a bit. You don't tend to get those colder winters. Those anomalies aren't as great as they were prior to 1985. So that's an interesting note. I will say, when you're talking about 10 cases and 10 cases, you can't draw a ton of conclusions on that because that's not a very big sample size. But nonetheless, it's interesting to note the trends that have been going on. So if we look at precipitation, you can also see a similar trend, wetter for the Pacific Northwest when we put all 21 La Niña events together. And then if we do prior to 1985 and post 1985, again, the signal washes out a little bit for precipitation also. So those are just for interest's sake. You can't really take much from that as far as a forecast, but that gives you an idea of what's happened in the past. And these graphics also came from this climate.gov website, the ENSO blog, and it shows the average snowfall for all La Niña winters, and then for weak and strong, and I think we should focus a little more on the weak events because that's what we're expecting, a weak to possibly moderate event. So this just shows you the average snowfall and what to expect, or not what to expect, but what's happened over the Pacific Northwest during past La Niña events for snowfall. If we look back at history, what I'm looking for here to tell me whether it's a strong or a weak or a moderate event. So here's our event last year, and I'm looking for negative 0.5 to roughly about negative 0.9 or negative 1.0 for weak, and then above that moderate. And then when I get to about negative 1.5, we're talking a more stronger event. So here's where we are right now. We just entered with September, October, November. We just entered La Niña conditions in that season. So we'll see how this turns out. We need at least 5 in order for this to be considered an event. So as you can see, that last week event we had, last time we had 5 seasons that overlapped, so that did qualify as an event, as weak and strange as it was. All right, looking back at the last year, you can see our event down here. This is December 2017, and here is the date line, about 180 here. And the central and the eastern Pacific, you can definitely see those sea surface temperatures are quite cool, and then warm just west of the date line, which is what we expect. Looking back at the latest weekly sea surface temperature departures, and we tend to like this sweet spot right here. Here's the date line, and here's South America right here. So we like this sweet spot right here to tell us what's going on with ENSO the best. And as you can see, that area is called Niño 3.4, and we're about, for this week, a negative 0.8. We have been the last couple weeks about that range. So starting in August, later in August, we started cooling off in that area. And that's what we're looking for to determine whether or not we're in La Niña conditions. One interesting note, we recently had a blog come out, it was last week, on the ENSO blog on climate.gov. And this shows this nicely, but we had that weak La Niña event last year, and then we actually ended up getting quite warm in between these 2 events, which is pretty unusual. This is actually the first time that's happened since 1950, when they've been recording observed ENSO events. Now, we tend to get back-to-back La Niña events. That's not unusual. What's unusual is this warm-up period that occurred between the 2 events. I don't really have a good answer as to why that happened, but it's definitely a research question that is being posed at our Climate Prediction Center. Why did that happen? It's an interesting question. So this just gives you the sea surface temperature departures for about the last month, again showing that date line right here, and everything to the east of that is quite cool, and then this the very warm temperatures in Indonesia, the maritime continent area, and the Western Pacific, where we would expect those during La Nina. Looking at the upper ocean, you can start to see that event. The ocean's cooling off in the upper 300 meters, starting later in July and moving through where we are currently right now. So temperature is quite cool in the subsurface. And here's the forecast. These forecasts are made with our Climate Prediction Center and the International Research Institute, and it's a combination of all of the models and tools, statistical and dynamical, and then also the forecaster input from the Climate Prediction Center and then the researchers at the International Research Institute. And what it's telling me is November, December, January, we're obviously in La Nina conditions, so that's pretty much a slam dunk. But as you can see, by the time we get to February, March, April, in that season, as we start to move into spring, it starts to wane. So again, expecting a short-lived event. And then after about March, April, May, moving back into that ENSO neutral phase. This just shows just the tools and the solid filled in dots or squares show that our dynamical models are tools, and then all of the statistical models and tools have a hollow center. And this yellow line right here is kind of where I always aim to look. And again, it shows, backs up what I just said. About March, April, May, we tend to get out of this negative 0.5 area and move back towards that ENSO neutral phase. Some of the models are starting to warm up very quickly, but it's way too early to tell, so I don't put a whole lot of confidence into those depictions at this point in time. So unfortunately, we're doing this on Monday, but actually we will be updating all of our seasonal temperature, precipitation, and drought outlooks on Thursday this week. So if you tune back in on Thursday to the Climate Prediction Center, all of the outlooks will be available by early morning Pacific time. But for the December, January, February season, again, this is honing in on what we typically would expect for La Nina, so cooler in much of the Pacific Northwest. Unfortunately, this portion of the southeast portion of Oregon and southern Idaho tend to be in that no man's land where we don't actually have any of our tools that are giving us any confidence one way or the other. So it's in that equal chances zone where there isn't really a forecast for that area. And then the three-month precipitation outlook for December, January, February shows is depicting a slight favor for wetter than normal conditions for much of Washington, much of northeastern Oregon, and much of Idaho. And then again, kind of in that no man's land, unfortunately, in the southern part of Oregon. And here's our seasonal drought outlook. The Pacific Northwest looks very good. Not expecting drought to be headed your way at this point in time. I don't think that's going to change with the outlook that will come out Thursday. I could be wrong. I'm certainly not the forecaster there. But one thing I will note is a little bit of this in northern West Montana. They're expecting that to improve and the drought to actually improve there and go away probably within the next 3 months. So again, check back with our forecasts as we get into Thursday. Sorry about that. It's just a timing thing. And I will leave you with the summary slide. Thank you.
All right. Thank you, Andrea. And now let's move on to our last speaker, Gabrielle Roche McNally. She'll update us on the Northwest chapter of the National Climate Assessment.
All right, thank you. And can you see my screen?
Yes, we can.
Okay, great. All right. So thanks again for joining my brief update today on the Northwest chapter of the National Climate Assessment. I work with the Northwest Climate Hub. We're a USDA organization that has a goal to bring science-based information to guide climate adaptive decision-making across public and private land ownership in farming, forestry, range, and tribal contexts. And I want to say a quick thank you to Chris May, who's the lead author for the Northwest chapter, for her great leadership and also for sharing some of her slides with me. All right. So here's just a little snapshot of our author team. It shows a great distribution of expertise, including experts who work in federal, state, university, tribal, and private sectors. So there's a lot of depth and breadth of expertise when it comes to the author team. One of the main foci of the NCA is to prepare an assessment of the literature on climate stressors in the region and to describe their likely impacts on sectors of concern. So you can see we have a depth and breadth of expertise to enable us to meet this goal. So for the purposes of the Northwest chapter of the NCA, we focused on the Northwest, which is characterized as Oregon, Washington, and Idaho. Originally, we'd hoped to prepare our assessment based on the unique and highly heterogeneous landscape across the Northwest, from the coastal region to the western lowlands and up the mountains and into the inland Northwest. That did change slightly, and I'll get into that briefly, but I do want to cover some of the climate stressors and impacts and how they vary across our region, since I think this kind of ties more into future projections around climate change versus our seasonal outlook that we typically cover here and the DEWS update. So when we think at coastal regions, we're looking at impacts such as erosion, inundation, flooding, sea level rise, storm surge, and wave hazards. We expect threats to critical infrastructure and human life and safety. Also impacts such as ocean acidification and warming, which will certainly impact our fishery sectors, shifts in marine species, and expecting more toxic algal blooms. When we think about the western lowlands in our region, we're looking at climate stressors such as higher temperatures and hydrologic changes. And there's lots of impacts here. So more flooding, greater health risks, climate migration into the region, lower summer flows challenging salmon survival in particular, and other fish species, higher winter flows also affecting riparian ecosystems, also increased wildfire risks, and then shifts in tree species and habitat diversity. When we get up into the mountains, we're looking at higher temperatures and more rain and less snow predictions. What this means are sort of earlier peak flows, lower summer flows, more insect and disease pressures, wildfire risks, shifting vegetation types, losses of biodiversity, impacts to air and water quality, and again, flooding impacts, and then changes to recreation and tourism, some positive and negative depending on the area. And then when we get into the inland, which we think of a lot of our agricultural areas and livestock production, rangeland management, we're looking at higher temperatures and heat stress impacting things like plant growth, forage quality, the quality of fruit, the health of our livestock, as well as farm worker health, increased pest pressures. And then we're also expecting seasonal changes, so changes in growing season, in the productivity of our rangelands, and again, reduced snowpack, reducing water availability. And we're thinking here, particularly in the inland Northwest, impacts to irrigation for agricultural production and a watering of livestock. So in order to sort of set the stage for the assessments, we held regional engagement workshops, and we held them in Portland and in Boise. What really emerged from these conversations was the importance of the uniqueness and diversity of the Northwest. We started to hear people talking about what they value about our region. So this wordle on the screen is created from the notes from the regional engagement workshops. And you can see many of the things that we value in the Northwest emerge, such as water, culture, farming, mountains, communities, jobs, etc. So these values really reoriented our organization in the development of key messages for the assessment. So we focused in the end less on geography and more on the values and uniqueness of the Pacific Northwest. So we've been instructed not to directly quote or distribute the National Climate Assessment, since the draft chapters are currently under review and are likely to change based on public comment and comment from the National Academies of Science. However, I want to share some highlights based on the assessment of science that we conducted to just highlight a few of the key messages from the chapter. So for the Northwest, we have 6 key messages. Here, starting as 2015 as a case study or a prelude of what may be more likely to come in the future given climate impacts and change. And then we focus on the natural resource economy, natural world and cultural heritage, infrastructure, health, and then frontline communities. We define those as folks who will be impacted likely first and worst by climate change. And we focus on tribes, farm workers, the urban poor, and homeless. So I'm just going to focus on 3 of here today, 3 of these key messages, or the sort of general outline of what we cover in the key messages, because I just don't have time to get into all of it. So 2015 case study, a prelude of what's to come. So 2015 is sort of an analog for what we might see as a new baseline in the future. This was the warmest year on record, which is consistent with high emission scenarios and projections for mid-century, and then consistent with late century projections under a lower emission scenario. We also experienced below normal precipitation and extreme drought. And this is consistent with high emission scenarios for the end of the century. And I'm going to touch on some 2015 impacts kind of as I go through a couple of these other key messages. So this key message had to do with rural and natural resource-based livelihoods. So there was definitely a focus on economics, but also on livelihoods and impacts to communities based on the natural resource sector. And we focused on farming, ranching, forestry, fisheries, and recreation. So a lot to cover. Example of some of the major takeaways, and then a linkage to some of the tie back to our 2015 case study. So we focused on sort of higher temperatures and reduced precipitation that's already impacting agriculture. We expect heat stress and reduced water availability as already impacting and continuing to impact plant, livestock, and worker health. And we tie this back to 2015 as one of the toughest farming seasons on record in our region. And then moving on to sort of forestry impacts, these again, higher temperatures and reduced snowpack as adversely impacting forests and forestry and causing increased or driving increased wildfire, pest and disease risks, impacting forest resources. And then again, tying back to 2015 as one of the biggest wildfire seasons on record. And then in terms of ocean impacts, higher temperatures and acidity are impacting fisheries, experiencing increased toxic algal blooms and changes in species diversity, tying again to the 2015 case study, which had the largest algal bloom on record, termed the blob, and extensive fisheries closures. So I'll just talk about one more of the key messages since I don't have that much time, but we, again, kind of similar format, just a couple of the highlights. So we focused on transportation, road and railway closures will result and have resulted from flooding, landslides, and mudslides, and we expect more of that in the future. We give a couple examples from 2015, both one in Tillamook, Oregon, in the winter of 2015 with heavy rainfall and high coastal water levels, so leading to flooding, culvert failures, road closures, and then impacts to access to health facilities. And then again, we cover a landslide that closed I-90 in 2015 as well in Washington. We also talk in terms of infrastructure about water availability and tie this to an example of in 2015, the Department of Ecology allocating, again, nearly $7 million for drought relief to support backup and emergency water for irrigation and human consumption. And then also to covering things like power disruption. And we use, again, this example from 2015 in August, the Goodell wildfire that caused sort of $3 million in damages and also some lost production at the Skagit hydroelectric project. And again, what I'm presenting here on these key messages is sort of their draft version. This isn't the exact language for the key messages. The way that you can actually take a look at that would be to go and provide public comment. So you can actually download a copy of these and review the Northwest chapter, as well as chapters for other regions in the country, as well as sectoral chapters that cover things from agriculture, forestry, oceans, marine issues. There's an international chapter, all sorts of information there. So I encourage people to take a closer look. The deadline for providing comment is January 31st in the new year. And I won't spend, just to cover briefly that you need to comment through the USGCRP review and comment system. You have to develop a brief account, and then you can go up and look for documents available for public review, and you'll see the NCA for Volume 2 there, and you can download it and do some good reading. Again, I'm encouraging folks to look at the Northwest chapter, but there may be other chapters that are of interest to folks on the call today, and you can comment online, or you can download a spreadsheet and then upload it at a later date. And then finally, there's a webinar for folks to get online on the 16th of January. There were some others, but they've already passed. So I encourage you to get online for that if you want to get a little bit more information. But this process of the assessment goes through multiple rounds of internal review, and now it's currently out for, again, public review as well as review by the National Academy of Sciences. And it's a really important opportunity for folks to take a look at what's being developed. And it's meant to be, this assessment is meant to be a useful document for folks who are doing planning and adaptation planning and a wide suite of other activities. So we encourage you to take a look and see if it is meeting your needs and has the information that is most up to date. So yeah, I'll probably just leave it there, but thank you very much. And again, you're welcome to reach out to me, but you're also welcome to go to the globalchange.gov website and reach out to folks at the national level if you have other questions. Thank you so much.
All right, thank you, Gabrielle. So if anybody has any questions, please feel free to type them in the chat box or in the question box, and we can ask the speakers their questions. We do have one question from Ruth Burris, and I think this is directed towards either John Abotsoglu or Andrea Baer. And the question is, what is forecast for the mid and upper Columbia Basin?
Well, I'm not sure exactly to that scale. As you can see, our outlooks are a bit broader. I have them on my screen, but I don't know if you can give me back. So can you? Yes, there we go. So for, I'm assuming they're talking about precipitation, whoever is asking this. Yeah, and I know these are just very general and they're seasonal, and it's just a slight tilt in the odds towards wetter than normal for that area. So I can't really get more specific, smaller scale than that. I don't know if John has anything at his disposal, but I'm sorry about that.
Yeah, I mean, the one thing that we have seen looking at La Nina type years, and this is often a little bit not obvious, but with La Ninas, we typically get really much more strong, more zonal flow across the region, and that brings much above normal precipitation to the areas that are favored, so western facing slopes. And in the Lee, though, in this basin, you have a little bit of your sort of, you do sort of are on the eastern side of the, if I'm looking at this properly, on the eastern side of the basins, there can be some different signals there. So it is a little bit more complicated because of the fact that, you know, when you're in the Lee and you have zonal flow with La Nina, that can result in some different patterns that show up.
So John, just some clarification on that question. It was in regards to the forecast snowpack in the mid and upper Columbia Basin.
Okay. Yeah, the mid-Columbia is pretty low right now. So there'd have to be a pretty good, make up quite a bit of snow there over the next 2 months.
Okay, thank you. Let's see, the next question is on the Northwest chapter of the NCA. And the question is, for the key messages that were presented for the Northwest chapter, are all of the examples presented with 2015 in mind, or are other years mentioned under the health key message, for example?
Oh yeah, no, great question. I think maybe my presentation made it sound like it was all tied around 2015. That's just sort of how I outlined the presentation here. But no, so we used 2015 as its own key message to describe that this is sort of an analog for what we might expect as a new baseline in the future climate regime in the Northwest. So we use that example. However, there are examples throughout the chapter from basically from the last National Climate Assessment about 4 years ago. We've been sort of building the literature from there. So we use more recent examples over the last few years. And then in the health, I would have to pull it up in front of me right now, but there are definitely examples both from sort of a specific date, but also we try to highlight some successful examples of adaptation efforts that might span multiple years and tying it directly to communities or issues of interest in our region. So I definitely encourage folks to get on there and take a look. So yeah, not just focused on 2015, but that was its own key message and wanted to kind of highlight some of the impacts for folks here today tying directly to that year. But there are other pieces there that I didn't represent.
All right, thank you, Gabrielle. And it doesn't look like I have any other questions. So if there's any other final questions, go ahead and type them in now. Otherwise, we'll end early.
Megan, this is Britt. I did see a question earlier about the October webinar recording and where that was on drought.gov. We have had a bit of a staff turnover and new staff coming on. Myself, I'm also new. We think that that was recorded and we're trying to get a copy of that recording, but I will make sure that the slides from the October webinar at least are up. And as far as today's webinar and slides, we will try to get that up on drought.gov by the end of the week.
Great. All right, I'm not seeing any other questions, so shall we wrap up a little early today?
Sounds good.
Okay, well, thanks everyone for joining, and look to the drought.gov website for the slides and recording, and stay tuned for the date for the next webinar, which will be sometime in February. All right, have a good holiday season, everybody.